Hi, everybody. We're going to be looking at section 1.3 today, which is about distance and midpoints. So we're going to go ahead and get started on that. Our goals for today. Our goals are, number one, to understand midpoint. And what that actually means and how we find it. So understand and calculate midpoint. Number two, understand and calculate the distance between points. Okay, so those are what we're going to be looking at. So a couple of these here, these words we've heard before. So midpoint is a point. Actually, for these, what I think we're going to do is we're just going to draw a little picture here. For each of these. So a midpoint is if you have a segment, these 2 points A and B, so this is segment AB. We write it like this, right? A and B are the endpoints. The midpoint is the letter, let's say C, the point C, that divides that segment AB into 2 congruent pieces. So segment AC and segment CB are the same. So we call C the midpoint. So the result here is that segment AC is congruent or the same size as segment CB. That's the midpoint. It divides a segment into equal pieces. So a segment bisector is really anything, any point, line, doesn't matter, that splits a segment into two congruent parts. So to bisect means to split or divide into 2, that's the prefix bi, means 2 congruent parts. Okay, so in this case here, C is the segment bisector. So we're going to go ahead and look at some of that, okay? So we have a midpoint here. So we're in our journal, student journal. I believe we are on, let's take a peek here. I believe we're on page 14. So if you should be following along and putting this in your journal as we go. So, so here we go. We have the midpoint of a segment is the point that divides the segment into 2 congruent segments. So just like we had up there. And then the segment bisector can be any point, ray, line segment, or plane that intersects the segment at the midpoint. So that just means it splits segment AB into 2 congruent parts. So in this case here, CD, this line, is a segment bisector because it splits AB into 2 equal parts. M is the midpoint of AB in your picture, okay? So let's keep going here. So now we talked about coordinates the other day, and the question was in our little Desmos activity, how do you find the coordinates of a midpoint? So let's kind of talk about what this is saying. So there's a little formula for it. This is x1 plus x2 divided by 2, y1 plus y2 divided by 2. I think the best way to go through this is do an example, right? So let's say I want to know the midpoint of the points 1, 6, and 4, 7. Okay, so when we look at a graph, if we plot those points, so 1, 2, 3, 4, 5, 6, there's 1, 6, 4, 1, 2, 3, 4, 4, 7 is just a little higher up here at 4, 7. So we want to know what the midpoint of that segment is. Well, we can almost estimate it, right? It seems like it should be somewhere around there. So if you look at this, it looks like it's almost like 2 or 3 and then maybe up to 6.5, 7, some like 6.5 maybe, but you can almost estimate it. So the way you could find that is if you think about how far apart are each of the coordinates. So like from 1, this is where the first x coordinate is, from 1 to 4, what is the midpoint of 1, 4? So 1, 4, 1 to 4 it's 3 units from here to here, so we got to go halfway. So halfway should be 2.5. Should be 2.5. That's halfway between 1 and 4. And then the other one was from what, 6 to 7. So what's halfway between 6 and 7? So to me, halfway between is 6.5. So the midpoint, visually, the midpoint, you can go ahead and just say it's 2.5 and 6.5. That's the midpoint of that line segment. Or you can use this little formula, which takes the average of the x's and the average of the y's. It's just that sum them and divide by 2, and you'll get the midpoint that way. So we can also find the midpoint by doing, here's our midpoint that we want. This is x1, this is x2, so 1 plus 4 divided by 2. And then over here, this is y1, y2, so we could do 6 plus 7 divided by 2. And then all together, we just need to simplify that a little bit. So on the top here, 1 plus 4 is 5. So we write 5 over 2. 6 plus 7 is 13. That's 13 over 2. And that is equal to, if you divide 5 by 2, you get 2.5. 13 divided by 2 is 6.5. So no matter how you cut the cake, you get the same sort of thing. So one way is more visually represented. The other way is more algebraic. Okay. So that is how one way you could find the midpoint, or you can draw a picture and try to just use the coordinates. Distance formula. Okay, this thing, it looks a little bit large there, maybe perhaps a little overbearing, but we're going to get through there in a second. Let's say I want to find this is called the distance formula right here. Okay. Let's say I want to find the distance between 2 points, A and B. So let's say A is the point 1, 3, and B is the point 4, 7. If I plot them on a grid, 1, 3. It's a bad line there. So 1, 3 would be here, and 4, 7. 1, 2, 3, 4. 2, 3, 4, 5, 6. Yep, there. So let's say I want to find this distance right here. That distance. Well, what we saw the other day is in Desmos, you can just do this, right? You can, or in our activity, we can just make a little right triangle and count blocks. So here's our little right triangle. So how far? I got to go from 1 to 4. So 1 to 4. So this is 3 units. And then from 3 to 7, that's another 4. So according to the Pythagorean theorem, our distance over here is like c. All we need to do is 3 squared plus 4 squared equals c squared. This is like a squared plus b squared equals c squared, where 3 is a and 4 is b. And then we simplify it. So that's 3 squared is 9, 4 squared is 16, and c squared, it stays the same. 9 and 16 make 25, c squared. Then you take a square root, and you take the square root of 25, and you get that this distance is 5. Okay, so this is my preferred way, is using the Pythagorean theorem, since we already know it, and drawing a nice picture, because I think it's nice and helpful with the visual. That's my preferred way of doing it, but you don't have to do it like that. Some people use the distance formula, and this distance formula here looks a lot like the Pythagorean theorem, doesn't it? Like it has a square plus a square, and there's a square root in it. So really the distance formula, it actually is the Pythagorean theorem, and you're going to see why in a second here. So let's say we do it with that way. That means the length AB is equal to, you'll see what I mean in 1 second. This has to be x1, y1, x2, y2. So x1, according to our formula, we have the square root. Okay, so for x1 and x2, we're going to put 4 here, 4 for x2 minus 1 for x1 squared plus 7 for y2, so 7 minus 3 y1 squared, and then we use the order of operations to simplify. So that's the square root. You do what's inside the parentheses first. So 4 minus 1 is 3. So that's 3 squared. 7 minus 3 is 4. That's 4 squared. Start to look familiar, doesn't it? Like, doesn't it look exactly like what's up here without the square root? Because again, it's the Pythagorean theorem, just written a different way with the difference of coordinates. Simplify a little bit. So you do everything inside the root first. So 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. And at the end, you get the same sort of deal. You get 5, okay? So, so this is 2 options to find the distance between 2 points. Okay, we're gonna do a couple little practice problems here, and then get you going, and you'll be all set. Okay, so identify the segment bisector of AB, then find AB. So segment bisector for this one, this is the segment bisector. That's the midpoint M. This is the segment bisector, which is ray MC. We write it like this. Ray MC, and then this one is line L because it passes through the midpoint right here. This is segment bisector. Let's try to find the length of AB on, let's say, the third one there. Well, the third one, the length of AB, we know this part is 26. Since these tick marks mean they're the same, that means that has to be 26. So AB should be just 26 plus 26, which is 52. 52 units probably. Okay. So let's do one with a little bit of algebra built in for us. Let's try number 6 here. So this is the segment bisector. This is the midpoint. So what does that mean? That means that it splits this segment EF into 2 congruent pieces, right? That's what those tick marks mean. But what does that mean? That means that EM has to be equal to MF. And according to our little expressions up there, EM is the same as 3x minus 4, and MF is the same as 5x minus 12. All we have to do is solve that equation to figure out what x is. So that's just undoing a few operations here. So we can add 12 to both sides because that's the opposite of subtracting 12. Then we'll get 3x. Now 12 minus 4 is plus 8. And the right side is 5x. And then we can subtract 3x on both sides. And when we do that, we'll end up with 0 here, and that's 8. 5x minus 3x is 2x. And then finally, you can divide by 2 to get 4 for x. And the question is, find the length of EF. Well, if I take 4 and plug it back in here, so 3 times 4 minus 4. 3 times 4 is 12, minus 4 is 8. So I know that EM is 8. Since they're the same, that means that this has to be 8. So in total, the whole segment should be 8 plus 8, which is 16, okay? I'm gonna hold off on doing these examples down here because I just did a couple examples with some coordinates up in the beginning. So these would be good practice problems to try. But I think for right now, we're going to end the video on section 1.3, which is all about midpoint and distance.